A goldfish supposedly has a 3-second memory. That's a myth, but your AI assistant has a real memory limit. And unlike a goldfish, it doesn't forget gradually. It forgets everything all at once, the moment you cross a line. The context window is the total amount of text an LLM, a large language model, can see at one time. Every word you've typed, every response it's given, every document you've pasted in, all of it counts against that limit. When you hit the ceiling, the model can't see what's beyond it. It's like working on a desk with a fixed surface area. You can only spread out so many papers. Slide a new one in, and something else falls off the edge. The model isn't broken. It simply cannot read what it can no longer reach. This stops being theoretical fast. Say you're building a customer support chatbot on top of GPT-4. A user has a long, complicated conversation, 30 back-and-forth exchanges. Around message 20, the model starts giving answers that contradict what it said earlier. It's not confused. It literally cannot see those early messages anymore. They've been pushed out of the context window. Or you're using an AI coding assistant and you paste in a large file to refactor. If that file is longer than what the model can hold alongside its instructions and your question, something gets silently truncated. The model works with incomplete information and gives you incomplete or wrong keywords answers. No error message, no warning, it just works with what it has. Context windows are measured in tokens, not words. A token is roughly 3 to 4 characters of English text. Context is 1 token, window is 1 token, but context window might be 3. OpenAI's tokenizer splits text in ways that don't always follow word boundaries. The practical rule: 1,000 tokens is approximately 750 words. Every model has a hard token limit. GPT 3.5 started at 4,000 tokens. GPT-4 Turbo supports up to 128,000. Google's Gemini 1.5 Pro pushed to 1 million. These aren't arbitrary, they're architectural constraints tied to the transformer's attention mechanism. Here's the mechanism. Transformers process text using a system called self-attention, which compares every token to every other token to figure out relationships and meaning. The problem is that comparison doesn't scale linearly, it scales quadratically. Double the tokens and the computation doesn't double. It roughly quadruples. That's why expanding the context window isn't free. It's computationally expensive, fast. To manage this, modern models use something called a KV cache, key value cache. As the model processes tokens, it stores the intermediate computations for each one so it doesn't have to redo that work for every new token generated. That cache lives in GPU memory. Larger context windows mean a larger KV cache, which means more memory consumed per conversation. At scale, this becomes a real infrastructure cost. And if this is the kind of thing you want to understand at that level, Stack Future covers one concept like this every day. When context length exceeds the limit, most implementations either hard truncate the oldest content or use a sliding window that drops early tokens. Either way, the model loses access to it, silently. You're building a document Q&A tool using the OpenAI API. You embed a PDF into your prompt, say a 30-page policy document, and ask the model questions about it. The document is around 20,000 tokens. You're using GPT 3.5 with its 4,000 token limit. Your request hits the API and comes back with an error. This model's maximum context length is 4097 tokens. Your messages resulted in 20,012 tokens. That's the moment. You have options. Switch to GPT-4 Turbo with 128,000 token support. Or, more scalably, implement retrieval augmented generation, often called RAG, where instead of pasting the whole document in, you retrieve only the relevant sections and inject those into the prompt. RAG keeps your effective context lean and lets you work with documents of any size without blowing past the token limit. Most production systems doing document search use exactly this pattern. The context window is the model's working memory, fixed, finite, and silent when it overflows. Knowing the token limit of whatever model you're using isn't optional, it's foundational to building anything that actually works. Next up, DeepSeek's inference optimizations and what they mean for running LLMs. Because once you understand context windows, you'll want to know how DeepSeek is changing the cost equation. If this one clicked for you, the like button is right there and it genuinely helps.